So you may have already heard about this, but apparently 13th gen and 14th gen i9 CPUs are having some serious stability issues. In fact, such a serious instability issue that even NVIDIA had to say something about it. So NVIDIA basically is saying, hey, if you're getting a message that pops up when loading a game that says ran out of video memory, it has nothing to do with the graphics card. It's actually because of a problem that has sort of crept up over time now with Intel i9 CPUs, 13th and 14th gen. So today we're going to talk about some ways that you can kind of, maybe if you're getting this crashing, if you're getting some severe instability issues with your 13th and 14th gen CPUs, and presumably out of the box settings, we'll kind of talk about what's causing it and how to hopefully fix it in the meantime while Intel is still trying to figure out what the hell's going on. The ViewSonic X2 4K LED projector is the world's first projector designed for Xbox consoles. Featuring screen sizes up to 120 inches, native refresh rates up to 240 Hz, built-in Harman Kardon speakers, and low latency gaming modes, the X2 4K gaming projector from ViewSonic delivers a truly customizable experience for both gaming and HDR cinema. To see our full-length video covering features and user experiences, follow the links in the description below. There's probably been some videos about this already, but I think it's important for me to do my own right here. Not only that, Falcon Northwest sort of kind of gave me some insight as to their own testing and what they think could be causing some of these problems, but I'm gonna give you sort of the Jay's 2 cents, super easy to digest, whether you have, I don't know, maybe you're what's that, gluten, maybe you're gluten sensitive, I don't know. What am I doing?
I don't know.
But I'm gonna try and make it as easy to understand as possible because I know a lot of people are not comfortable with going in here and there's a million switches. It's like sitting down in the cockpit of a A380 Airbus and going, okay, push the right buttons. You're like, I don't know what to do. You're afraid you push the wrong one. You can eject all the passengers or something. So anyway, you have to understand how the CPUs work. And I've done videos about this recently where I've talked about the fact that many of the motherboard manufacturers are too aggressive with their enhanced profiles designed to take advantage of the K-SKU CPUs. So Intel has a couple of different power profiles slash performance profiles for their CPUs. There's the performance profile, which is the K-SKU stuff. And then there is like an extreme profile, which is intended to be able to push those limits a little bit farther. And the manufacturers and vendors for the motherboards are allowed to play within a specific range. I feel like some of the motherboard manufacturers take liberties that are beyond the Intel limits, and some of them get mad when I point that out, but that's absolutely the truth. Many of the motherboard manufacturers are pushing the CPU beyond its limits. So I can't wait to find out what some of the final resolution is and what some of the final determined problems are with these CPUs and whether or not it has anything to do with the manufacturing process of the CPU. Maybe they were too close to their, there's an envelope where stability sort of, you go outside of that envelope, stability is, who knows? It could be stable for a month, a week, a year, 2 years, 1 day. Degradation can happen. Degradation happens to all silicon and all ASICs. The thing is, most of the time that degradation process is so slow that you would have upgraded the CPU many times over before it would ever reach its end of life due to wear and tear. But if you start to up voltage in amps and pushing more power that's necessary through these CPUs outside of their specified range, you can speed up that degradation process. That's where the motherboards come in. If they're too aggressive, then they can speed up that degradation process. As long as they stay within the specified perimeters that Intel says is safe, that won't be a problem. The problem is, as I've showed you many times, they do end up outside of that safe range. Let's talk about that. This is an ASUS motherboard, as you guys may have seen a million times in my videos so far. And the reason why I'm using the ASUS motherboard is because it's the only one I have set up right here for demonstrating how to keep your CPU as safe as possible, or in this instance, crash-free as possible. So what we're gonna do is I am out of the box default settings, right? F5, load optimized defaults. I wish there was a just load defaults, no optimization, just load the defaults, but that doesn't exist. So if I go over here now to Extreme Tweaker, you'll notice I don't have XMP or anything loaded. It's just all stock, right? If I go over here to Extreme Profile, auto let BIOS optimize. So that's the auto let the motherboard vendors logic handle all of the CPU stuff. That's supposed to be within the spec of the CPU. Unfortunately, let BIOS optimize is very far outside of the realm of Intel safe. Why? And by the way, this is the latest BIOS. I need to point this out because people sometimes often are like, well, what BIOS are you on? So I am currently on BIOS 3401. That is the latest. It came out 3/18/24. This is the latest BIOS for this particular CPU. Anyway, digressing, we're gonna go back to Extreme Tweaker. We're gonna check out a couple of things here. First things first, you notice the performance core ratios are all default. 55x, which is for the all core, it goes up to 5.8 or 58x for a single core or two core workload. If I go to Intel CPU power management, you'll notice that things here are not within the Intel spec. So if we talk about this here real quick, the current CPU core cache current limit is set to 511.75 amps. That number for the performance profile from Intel, as specified by Intel, is 307 amps. The extreme profile is 400 amps. Why it's set to 511.75, I don't know, but it is. Now, amps and watts and all that is a correlation, right? It's a mathematical equation. Doesn't mean it's necessarily going to pull 511 amps, but it could, okay? Now, how could it potentially pull 511 amps? Well, let's go down here to our short duration power package limit, 4,095 watts. Essentially, that is unlimited. Because as Phil noted, if that were to be 4096, it would actually be 0 because it's binary, right? So 4,095 watts is how much wattage the CPU package is allowed to draw if it could. Essentially unlimited. Do you know what's going to hold back the limits of that particular type of parameter? Your cooler. So you're going to hit 100C or close to it, guaranteed over time, and your duration limit. Now the duration limit is set to 96 watts, or 96 seconds. So after 96 seconds, that wattage would drop to 253. That's not necessarily a problem. The question is, if you are doing tasks that are constantly hitting this number, not actually that number, let's say it would probably go to about 320 to 350 watts, depending on the CPU. 320 is probably where it would realistically go, which, by the way, if you look at the chart again, you'll see that's actually the short duration power limit for the KS SKUs on the 14900 KS and the 13900 KS. That's how they're actually getting that up to 6 gigahertz clock, is they're pumping more power to it because they were better silicon quality. It's not a different chip in any way whatsoever, other than it performed really, really well. So they upped the limits on that. I have a 13900 non-KS, just a K. So mine should realistically be 253 watt and 253 watt, realistically. But it's set to unlimited out of the box. This is where people put air coolers and stuff on there, and then they fire up their Cinebench or whatever because they want to benchmark. Look, it's like having a very fast car. If you have a fast CPU, you want to drag race it. How fast is it? Let's go find out. You're not going to drive around town like that, going foot to the floor, stoplight to stoplight, but every now and then you might. If you blew up your car going from stoplight to stoplight because you did something stupid to the modification of the vehicle, that's on you, right? But what if the modification is being done without you knowing, which is the out-of-the-box settings? So what I'm going to do right now is just with these settings, I'm going to go ahead and go into the Windows, and I'm going to run a Cinebench R23. I get pushback from motherboard vendors when I use Cinebench because they're like, that's not realistic. Guess what? It's a process. It's a process I can run. The CPU needs to be able to do anything I could potentially tell it to do without causing itself harm or crashing. It is a very fair test. Deal with it. So we're going to test that now and see what our temperature gets up to. We're using a 360 millimeter AIO from EK. It's actually a pretty decent AIO. It's probably going to keep it into the 90 degree, maybe 92 Celsius range, which is actually really good considering the fact that it's not being given a limit as to how far it's allowed to boost for that first 56 or 96 seconds. Default, by the way, is 56 seconds for Intel. So everything is lifted, as you can see, with the out-of-the-box settings. Now, I know this sounds very similar to my complaint about motherboard manufacturers doing these out-of-the-box settings that are not Intel specific. I feel like the out-of-the-box setting 100% absolutely ethically needs to be Intel limitations, not whatever the vendor has decided that limit should be out of the box. It should be the Intel limits. Then there should be a manual included with the motherboard to say, if you have better cooling and you want to up these limits, here's how to enable a profile setting. That's the way it should be, period. End of story. Don't write me 5-page emails telling me how I'm wrong. I'm not. That's the way it should be. End of story. So let's go ahead now and take a look at Cinebench. As soon as I hit this, it's going to go to a much higher number. 318, 317. Like I said, that's not bad. I mean, our temperature is actually 89, 88, 89. right? So 315, 320 watts, that's actually not terrible. If I were to add clock speed to that, let's say I was to go in there and add 56 multiplier, the voltage goes up, the heat goes up because there is what's called a voltage to frequency or a VF curve. So you have voltage and frequency which are tied together. So the higher the frequency, the higher the voltage. Exponentially more heat as you do that. There is absolutely no reason whatsoever an Intel Core i9-13900KS out of the box with a 360 AIO should be hitting 89 degrees. Our score is a 39,951. One of the things I want to look at right now is how much score do we lose by actually going to Intel limits. Because remember, Cinebench is a drag race. Keep in mind that was one loop. The longer we let that run, the hotter the coolant gets because it's taking in all that heat, the higher the temperature will go and the clock will start dropping. That's kind of the bad thing about it pumping more watts in heat than it really needs because of the fact that as the temperature goes up, not only is there a voltage and frequency curve, there's also a temperature and frequency curve or thermal velocity boost. So thermal velocity boost allows it to boost higher or longer depending on cooling, but guess what? As the temp goes up, there's also a curve going down where if the temp gets too high, frequency has to come down because voltage has to go down with it. Oftentimes the voltage kind of stays and the frequency just goes down. So it sucks, but that's the way that it is. Let's go in here and I'm going to show you now how to kind of force the motherboard to put all of the correct settings back. And this is, again, not a definitive guarantee as to why your CPUs may be crashing if you're dealing with it, because unfortunately what Falcon has found is that some of the CPUs, even new out of the box, having never been used, are crashing at stock speeds. They're crashing at stock voltages. They're crashing at, and voltage, by the way, I want to point out, I see people all the time in forums and internet discussing, well, my volts is this, my volts is that. Why is my volts different? I have the same CPU. No two CPUs will run at exactly the same voltage. So the VID is actually burned into the CPU. The CPU is telling the motherboard what kind of voltage curve it should use because that has everything to do with the silicon quality, has everything to do with the ASIC quality. So that voltage is unique to that particular CPU. CPUs that maybe have a lot more voltage leak or whatever might require more voltage. The ASIC quality has everything to do with the type of voltage that you need for the SO, I thought someone came in. The ASIC quality has everything to do with the type of voltage that's needed to make that part run. Some of the CPUs that were crashing out of the box had to be underclocked all the way down to 5 gigahertz to become stable. That's a loss of 500 megahertz out of the box. That's terrible, obviously. You need to get everything you paid for. This is our culprit right here, the Auto Let BIOS Optimize. That needs to be disabled. Enforce all limits. If I were to do the remove all limits, then that second 253 watt would turn into a 4095. So it would then we would have short and long be matching. If Cinebench took longer than 96 seconds to run, or if I had it on a loop for longer than 96 seconds, then we would have seen the core clocks drop down to probably about 5.2 at 253 watts. And our temperature would have dropped down significantly with it as well. So we're gonna do enforce all limits. Now if we go over here to our power management, you can see right here, it's still at 4095, 96, and 253 because until we restart, we're not gonna see those limits take effect. So if we make that change and you wanna see what the differences are now, we need to reboot. Oh look, 400. Remember that chart, how we showed 400? So already it was 511 because it has to have watts and amps, they're correlated, right? There's correlation there. So for the 4095, they had to go up to 511 amps, otherwise it would not have been able to go higher on the watts if the amps don't go up also. So that number was probably just arbitrary because of the 4095, it probably was still only pulling maybe 430, maybe 420? No, 420, so that's just because of the higher voltage and watts are available to it. When it drops down to 253, it still would have been a max of 400. So here we go, it should be 253 on both and 56, there it is. There's a lot of other things that we could go in here and sort of mess with, but I don't think we need to, because this should get us now what our out of the box settings are for Intel. This is the way it should come out of the box. And we may not have potentially had motherboard vendors. I'm speculating, but I think it's a double-edged sword where I feel like to compete with AMD, Intel had to push the 13th gen and 14th gen to the limit And by the limit, I mean the absolute razor's edge of stability at out-of-the-box speeds and settings to be able to deliver and beat. So the part of the problem here too is Intel kind of knows all this, but they also really want to be faster than AMD. And so this is an okay thing for them to be, this is acceptable failure rate to maintain our lead over AMD CPUs when it comes to consumer desktops, right? Unfortunately, I've had too many people emailing me telling me they're getting random crashes on their 13th and 14th gens. I did get an email recently from someone saying, what's wrong with my GPU? It says out of video memory. I had never seen that before. And it wasn't until I read the article and then Phil and I were talking about it where I didn't know that NVIDIA actually had to make this statement saying, it's not your GPU, it's your CPU, which seems very counterintuitive, but that's the way it is. So let's go back over here to Cinebench. Our score was a 39,009 something, I think, somewhere around 30, I can't remember. Phil could put it up on the screen right here. I know we're gonna lose score because we're not gonna get that additional 320 watts available to us, which means, not additional 320, but up to 320, which means that actually it's up to 4095, but 320 is what it wanted, okay? There. We don't have that available to us now. It's 253 immediately, and that's just what it's gonna run at nonstop. So it's gonna clock down pretty much from 5.5 and 4.3 instantly down to probably like 4.4, 4.3, and then maybe bounce between 4.2 and 4.3. And our E-cores will probably drop down to 4.2, maybe 4.1. But we should see some significant reduction in our temperatures. And I know you can't really hear my fans, but my fans are not gonna be blaring either, because on the previous test, they went pretty loud, pretty quick because of that temperature hitting 89C, 90C. So here we go. So if you look over here, package wattage, you go 253 and just stay there. There it is, 253, 252.95.9. It's so cool and quiet now, I can barely hear my fans. It's at 5.2 all-core, 5.1 all-core, just like I said. 74C on the die, 76. I mean, that's a beautiful temperature for that load. And a score of 37,866. This is for a different take that we ended up not using in this video, but I predicted it would be a 37,853, and that's an 866. Yeah, I know my stuff.
I know my Nice, all right, and action.
So that's honestly it. It sucks because realistically, the reason why you get a K-SKU is because you want to overclock it. But you don't know right now whether or not the CPU is just asking for a very slow, miserable death by overclocking it. So it's my recommendation, if you're running a 13th gen or 14th gen i9 SKU, especially a K SKU, to go into your BIOS for whatever your motherboard manufacturer is and make sure you're enabling Intel default limits, not motherboard manufacturer limits. I don't care if it's Asus, ASRock, MSI, Gigabyte, they all do these additional limits because they're allowed to. Intel encourages it for the reasons I already said. Intel wants the CPUs to be beating AMD at all costs, including the cost of your CPU stability. So until something comes out from Intel's camp, which is taking a lot longer than expected, by the way, it is highly recommended you go in here and enable the Intel limits and leave it there, because of the fact that stability can really only be partially guaranteed at those limits. If your CPU is still crashing and doing odd things, you might be one of those unfortunate people that have a defective 13th gen. There's a lot of them. I've had a lot of emails from people, which means you'd have to talk to Intel about RMAing it. In fact, one person told me that Intel RMA'd their CPU and let them keep the bad one. So I don't know, maybe that's a possibility if it still works in the meantime. But if you find yourself still crashing, then you need to go into that multiplier, which is at 55, and then try 54, or then try 53, and continue to downclock your CPU until you find stability, until you can get a replacement CPU. If your CPU continues to crash at stock speeds, it is defective. Notice all of this talked about right now had nothing to do with memory, had nothing to do with memory controller or XMP profiles. That's a completely different topic when it comes to stability. And if your CPU is already having stability problems, enabling XMP can potentially make those problems even more wonky and crazy, because the issues may look like they're memory related when they're entirely CPU correlated to begin with. So anyway, there you go. I hope this video has helped. It's very similar to the ones I've done in the past, but this time it has actual market data behind it saying CPUs are failing or going bad or crashing. And the longer these are out, if it's a degradation issue because of high watts and amps and stuff, it's only gonna get worse as time goes on. That's how degradation works. All right, guys, if you've had a defective 13th or 14th gen CPU, put in the comments below how that went for you. Did Intel warranty it? I'm curious. I bet you most people would start to think it's their RAM or even their motherboard. I think most people would just not think their CPU is defective, but I really want to hear from you guys if you've had defective CPUs. Intel's correction for this, I don't know if it could be done at a motherboard BIOS level. If the CPU itself is having stability problems, that would potentially be a microcode problem. But I don't know how you could fix that remotely. That's a hardware problem at this point. So who knows? I think it might end up being something like the 10th gen. Remember we had 10900K, which they had very hard time maintaining yields on those, which meaning that not enough silicon was qualifying for that chip. So they made a new SKU called the 10850K, which was only 100 megahertz slower. Are we gonna see a 14850K?